Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here is a problem for today for exam P on probability. Let x and y have the joint probability density function f sub xy of xy equal to 5/16 xy squared for 0 less than x less than y less than 2 and 0 otherwise. So you can see that both x and y are between 0 and 2, and that's 2 by 2 square in the two-dimensional plane. However, x is less than y, which means that the only points where the density is positive lie below the diagonal line of that square 0, 2 by 0, 2. So from the square of length 2 for x between 0 and 2 and y between 0 and 2, the only points that matter are those below the line where above the line where y equals x, because x has to be less than y or y has to be more than x. So what is the marginal density function of x for x between 0 and 2? And here's the solution. So for x, for which we doing the calculation of the marginal density of x, its density can only be positive when x is between 0 and 2. And remember, the only values of y that we consider are more than x. So in general, the marginal density of x is the integral from minus infinity to plus infinity of f sub xy of xy dy over all possible values of y. So that y runs from minus infinity to plus infinity, but really in this case you can see immediately then only between 0 and 2 this density can be positive. But between 0 and 2, y doesn't run from 0 to 2. It runs from x to 2 because y has to be more than x. So this is actually equal to the integral from x to 2 of 5/16 xy squared dy. And we're taking the integral with respect to y, so 5/16 x is just a constant. And the integral of y squared is 1/3 y cubed. And we evaluate that from y equals x to y equal to 2. And what we obtained is 5/16 x times the value when y equals 2, which is 8/3, minus the value when y is equal to x, which is x cubed over 3. Okay, well then we multiply it out, and this becomes 5/6x minus 5/48x to the fourth, and that's the density we're looking for, and that's answer E. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.